Stoichiometry is the method by which, if you know the amount of reactant, you can predict the amount of product that's going to be made. If you know the amount of product that has been produced, then you can determine how much reactant has been consumed. If you hear the term perfect stoichiometric, proportions, this assumes that there is no, let's say, reactant left over. Like you mixed everything in the perfect ratio that matches the equation. So if you had 6 times 10 to the 23rd molecules of nitrogen, since you'd need 3 molecules of hydrogen for every 1 molecule of nitrogen, a perfect stoichiometric proportion would be 3 times that number, or 18 times 10 to the 23rd molecules of hydrogen. And this, of course, would produce 12 times 10 to the 23rd molecules of ammonia, or 2/3 the number of molecules of hydrogen, or twice the molecules of nitrogen, because the ratio is 1 to 3 to 2. Now, you can also think of this in terms of moles, which is primarily what we're going to do here. So you can think of this as being, for every 1 mole of nitrogen, we would need 3 moles of hydrogen to make 2 moles of NH3. What, on the other hand, would happen, let's say, if it wasn't something we could easily do in our head? So let's say we had 0.079, I'm looking at this one right here, moles of hydrogen. Well, how many moles of ammonia would be made? How many moles of nitrogen would be consumed? We can figure out both of those things by looking at the ratio, right? We know that for every 3 moles of hydrogen, right, we're going to be consume 1 mole of nitrogen. So we can do this as a factor. We go for every 3 mole of H2, 1 mole of nitrogen, and that's basically just 1/3 of that number. And I'll calculate that in a moment and put it up. Also, we can figure out how much ammonia is going to be made. So we can say for every 0.079 mole of H2 that is being consumed, how much ammonia is going to be made? Well, according to this equation, for every 3 moles of hydrogen, now notice I'm canceling this out, right? This is going to cancel like this. I'm going to get 2 moles of NH3. So our final result is we would get 0.0263 mole, and the H2's cancel out here, so we get N2, and we would get 0.0526 mole of ammonia. In sig fig, so we have to cut off here, so our answer would just be 0.026 moles of N2, and for rounding purposes, we could stop right there. By the way, the 2 and the 3 and the 1 and 3, those are exact numbers, so those don't affect our calculation. So we would think we get 0.052. We're going to round up, so our answer would be 0.053 moles of NH3. So on this page, what we have is a problem in which we're given the grams of hydrogen and asked how many grams of ammonia are going to be produced. Now, you can use the mass ratios. That is possible, but you're not going to see me doing that or any other professor doing that or anything in the textbook showing that. However, we could consider that for every 28 grams, right, of nitrogen, there's going to be 3 times 2, or about 6 grams of hydrogen to produce about 2 times 17, or 34 grams of ammonia. That's a true fact. We could use that ratio if we want to figure out how much ammonia is going to be produced. You're not going to see that. The expectation is you're going to do everything in moles. So let's take our grams of H2 and let's convert that into moles. And from the moles of H2, we're going to get the moles of ammonia, or NH3. So for the first step is to convert this to moles. So I've looked up the formula mass of hydrogen, and it is 2.016 grams of hydrogen is 1 mole of hydrogen. And after that step, I will have canceled out, and I will know the number of moles of hydrogen. Notice how nicely labeled that is. Once I've completed that step, I'm going to use the ratio in the equation to determine the number of moles of ammonia. Now, this is a pretty easy one because for every 3 moles of hydrogen, I'm going to get 2 moles of ammonia. Right? So I'm really just multiplying this by 0.66, right? But if you don't catch that, let's just label that whole thing out, right? So For every 3 moles of hydrogen, I'm going to get 2 moles of ammonia. That's my 0.66 right there, because that's 2 over 3, or 2/3, which is 0.66. At the end of that step, you'll have the moles of ammonia. The final step will be to determine whatever is being asked of you. In this case, it's grams of ammonia. So the final step will be to take this and to go for every 1 mole of ammonia, it will weigh 17.03 grams. And then basically multiply all the numerators and divide all the denominators in no particular order, because there's no order of operations for multiplication and division. It doesn't matter what order you do it in. When you do this, your calculator gives you 71.6509 grams. Now, since this number that you started with has 4 sig figs and everything else has 4 sig figs, it's not an exact number, because all those coefficients are exact. Those are counting numbers. You're going to round this to 4 significant digits. So you're going to cut it right here, and your final answer will be 71.65 grams. On the next slide, I'm going to just do a little more practice, and I'm going to try to show you how there are certain shortcuts when you're carrying out stoichiometry.